you are welcome again in our class, Organic Chemistry, and continuous our subject with the amines family. And we stop to the reaction of amine with what? With nitrous acid. Reaction of amine with nitrous acid. So nitrous acid, inorganic acid, is the OH, this is the nitrous acid, is OHNO, that meaning HNO2. This is the nitrous acid. How the nitrous acid it will be formed? It will be formed between the reaction of the HCl and sodium nitrate, the NaNO2. So the reaction here it will be happen to be start of the protonation of the the oxygen atom. So the oxygen atom it will be take a proton from the HCl to give you the nitrous acid. So the nitrous acid in acidic medium again, it will be further acid-base reaction and take a proton from the HCl to give you OH2 and positively charged. Okay, all the times we say this group, when we have this group, it will be good leaving group. All the times, okay? We say it will be good leaving group. It will be leave as what? As H2O. That meaning H2O molecules, it will be cancelled from this compound to give you H2O and what? And nitrosonium ion. Nitrosonium ion طلبة is the nitrogen double bond oxygen, and we have positive charge on the nitrogen. For this reason, it will be what? Allotrophil or electrophil? Okay, it will be electrophil. So the amines, if you have amines, can be react with the electrophil, can be work as nucleophile. The amines, yes, can be work. Why can be work as nucleophile? Because we have the أنشب electron on the nitrogen. Okay, so the amines it will be work as nucleophile. It will be work also as base. Yes, as base as we know. So reaction of the nitrosonium ion with what? With the primary amine. So nitrous acid react with the primary alkyl and aryl halide. Look, primary, not secondary, not tertiary. Primary alkyl and aryl amine to form what? To form diazonium salt. Diazonium salt. It is ion for the two nitrogen atom. Di yani two, azo two nitrogen. Okay, but it will be salt. So this reaction is called diazotization. Is the form for the diazonium salts. Okay, so the general reaction here, the general reaction for the diazonium salt is a primary amine. طبعا aliphatic or aromatic, both of them. Okay, but the useful in organic synthesis is the aromatic, not the aliphatic. And we will see why the aliphatic it is not useful in organic synthesis. So the primary amines it will be react with nitrosonium ion. This nitrosonium ion it will be formed by the reaction of NaNO2 with HCl. Okay, that meaning the amine it will be react with nitrous acid. The nitrous acid, how it will be formed? To be formed between the reaction of NaNO2 with the HCl. Okay, with the HCl to give you alkyl diazonium salt. This is the alkyl diazonium salt. Look, we have R, N, and positively charged. Okay, positively charged, and the negative part is the Cl minus. So, example for this reaction, this aniline, it will be react with NaNO2 HCl to give you aryl diazonium salt. This is one example about the diazonium salt. So the mechanism for this reaction consists many steps. طبعا the many steps of the mechanism is, you can write here, is acid-base reaction. It begins with what? With nucleophilic attack of the amine on the nitrosonium ion. That meaning the amine it will be attack this electrophile. We say the amine will be nucleophile, attack the electrophile. Okay, attack the electrophile. And it can be divided into two parts. This is the mechanism. It will be in the two parts. Two parts. Parts number one, two parts. Formation of an N-nitrosonium amine followed by loss of the H2O. It will be lost the H2O from the compound. And I will show the mechanism in the next slide here. Look, I will explain for you the mechanism. This is the main two part. Part number one, part number two. The part number one, look, unshapophilic electron on the amine will be work as nucleophile, have a nucleophile. Attack the electrophile, attack this nitrogen. And we have a new bond between this nitrogen and this nitrogen. And it will be give you this intermediate product has positively charged on the nitrogen. Now, how we can remove the positive charge? By acid-base reaction, by remove a proton. Where's the proton? We have two proton here. Okay, remove the first proton by Cl, remove it, and it will be give you N-nitrous amine. This is the first intermediate, N-nitrous amine. This N-nitrous amine, in part 2, it will be go to further reaction. It will be protonated, the oxygen atom by the acid. يعني unshapophilic electron. Take a proton, and it will be give you this intermediate. Now, this intermediate, we have positive charge on the oxygen. What we have to do now, the Cl remove the second proton. Okay, first proton, go. Okay, we have to remove the second proton. The Cl minus remove the second proton, and both the electron make here pi bond, and the pi bond it will be open to the oxygen to give you this intermediate. Okay, to give you this intermediate. Now, OH is base now. It will be work as base, attack the proton. Take a proton, that means protonation of the hydroxyl group for this compound to give you this intermediate product. And we have positively charged on the oxygen, OH2 positive. OH2 positive is what? Good leaving group. Okay, now unshapophilic electron make triple bond, and this leaving structure give you diazonium salt. Diazonium salt. Okay, diazonium salt. Two main part. Part number 2, three proton transfer reaction lead to loss the H2O. What meaning here? Look, this is nucleophilic attack. This, what this? Acid-base reaction. This, talaba, acid-base reaction. This here, yes, here in this part, acid-base reaction. Okay, here we have a new pi bond that will be formed. Okay, what we have here? Acid-base reaction. Okay, proton transfer. 3 proton transfer. Yani 3 acid-base reaction here we have. Okay, to give you diazonium salts. To give you the final diazonium salts. This is the mechanism how diazonium salts it will be formed. Okay. Is it clear for you? Part number 1, part number 2. Do you have a problem with here with part number 1? This is something not clear for you. Nothing. No question. Okay. Now, aryl diazonium salts, I said to you before that in the last slide, the alkyl diazonium salt, they are not useful in organic synthesis. Now, here he talked about the alkyl diazonium salts are generally not useful. Okay, look, it is not useful compound. Not like aryl. Aryl useful, but alkyl, they are not useful. They readily decompose below room temperature to form carbocation. Look, I will give you here example with alkylamine. This alkylamine, yes, alkylamine. This alkylamine, it will be react with Na, NO2, HCl. Directly, this NH2, it will be converted to what? To the N2 diazonium salt, to the N2 positive Cl. This is the diazonium salt. What is the problem with this compound? The problem with this compound is what? Unstable. Okay? Unstable. This N2 directly, this the N2 is good leaving group. N2 is good leaving group. It will be leave the structure and give you what? Carbocation. Now we have carbocation. And we learn before that about the carbocation. Maybe we have what? Rearrangement. Yes? Maybe we have the carbocation can be entered to the elimination reaction. Yes, maybe the carbocation can be entered to what? To the substitution reaction. So, what meaning that if you have carbocation in your mixture reaction, this is your mixture reaction, and you have carbocation, that meaning the product also it will be what? It will be multi-product, not one product. That meaning it will be multi-product, give you products of substitution, maybe products of elimination, maybe products of another side reaction. For this reason, it is not useful. Okay, not useful. You want something, but your reaction give you many things. It is not useful. Okay, it is not useful. This is the problem with what? With alkyl diazonium salt, with alkyl amine. Okay, alkyl amine, they are not useful. So, but on another hand, by another way, the aryl diazonium salt are useful in organic synthesis. Okay, why? Because the aryl diazonium salt, they are isolated, okay, and they are stable under what? Not above, under 0 degree. Okay, above 0 degree, they are what? Unstable. Also, if you work on the lab, so in organic lab, maybe you have this type of a question. You say, make this step in ice bath. Yes. Why in ice bath? Because the diazonium salt above 0 degree, they are unstable. Okay, above 0 degree, they are unstable. So this starting material, they are useful to enter to many kind of reaction. We take it inshallah. So what happened if you use secondary amine, not the primary amine? Primary amine, talaba, how many hydrogen we have it here on the nitrogen? 2 hydrogen. Okay, what happened if you use secondary amine? What happened if you use secondary amine? طبعا directly secondary amine, it will be enter to the what? It will be react with NaNO2HCl, the nitrous acid, but it will be stopped to here. It will be stopped to here, to this intermediate, to this N-nitrosonium amine. N-nitrous amine, don't go further to the diazonium salt. Why? Look here, because we don't have a proton. There is no proton. There is no protons, okay? There is no proton. But if you replace this R group with a proton, like a primary amine, it will be further go to the, give you diazonium salts, okay? So it will be react, yes, secondary amine will be react, but there is no diazonium salt. It will be stopped here to the N-nitrous amine because there is no additional hydrogen to remove it and give go further to another steps for diazonium salt, okay? So this, it will be happen if you use secondary amine. So diazonium salt, it is just selective for what? For primary amine. Okay, amines aromatic or aliphatic. Hardo can give you the diazonium salt, but aliphatic, they are not useful because they give you unstable diazonium salt and give you carbocation from the diazonium salt. And the carbocation, we have a problem with the carbocation. We have problems with the carbocation. So here, the mechanism for the secondary amine, I say to you, it will be thick. It will be nucleophile attack the electrophile nitrosonium ion and give you this intermediate. Look, just we have one proton. This proton will be removed by acid-base reaction and will stop here. Khalas, it will be stopped here. Don't go further to the next steps. Okay, it will be stopped until here to this compound N-nitrous amine. N-nitrous amine. So look to this. Homework, it is a question. Draw the product formed when each compound is treated with what? دائما NaNO2HCl يعني diazonium salt. Okay, diazonium salt. Look to this first one. We have aniline and aniline substituted with methyl group. Any group, it will be react with NaNO2HCl. This? No, NH2. NH2, it will be react and give you N2Cl, diazonium salt. So look this secondary amine. Secondary amine give you diazonium salt? No, give you this compound. Give N-nitrous amine. N-nitrous amine. Okay. This is also secondary amine. Give you N-nitrous amine. Write the product. You have to write the product. Okay. This was this primary amine, not secondary. I have a secondary. I have a secondary. This is a primary amine. Primary amine what give you? Give you diazonium salt. But it will be decomposed to the carbocation. It will be decomposed to the carbocation and give you secondary carbocation here. Okay? This group, it will be converted to the diazonium salt. Yeah, it will be converted to the NO2, but يعني N2Cl, but the N2Cl it will leave the structure and give you carbocation here. Okay, give you carbocation. Yes, just give you the carbocation as intermediate, and the carbocation can be entered to the elimination, give you alkene, give you substitute, give you many compounds. Okay, but the main intermediate is the carbocation. Do you understand? This homework for you. Write the product when this compound react with NaNO2 HCl. So, why we study the diazonium salts? Now, why we study the diazonium salts? طبعا aniline, this is the aniline. This is the aniline. Pay attention here. This is the aniline. Aniline, it will be converted to the what? To the diazonium salts. This is the diazonium salts. Okay. Now, why we study the diazonium salts now? Why? What is the important for this group? What is the important for this group? In organic synthesis, yes, this group can be converted to what? To many groups. We said Z atom. That meaning this group can be replaced by another functional group. Can be replaced, for example, by OH. Can be replaced by fluor. Can be replaced by iodine. Can be replaced by CN. Can be replaced by hydrogen. Okay? Can be replaced by مثلا aldehyde. Okay? Like that. Can be replaced by amine. Like that. Okay? Can be by reduction of the nitrile group. So, for this reason, diazonium salts, they are useful because can be entered to the substitution reaction to produce another functional group. For this reason, they are important. Yes? They are more important. So, allyl diazonium salt undergo two general reactions. Number one, this is the reaction, substitution. This the reaction, substitution. Number two, the coupling. Okay, we will talk about number one now. Number one is undergo to the substitution reaction. That meaning we replace the N2 plus Cl minus the diazonium salt group by what? By Z. Z طلبة an atom, ek atom, or group of atom, OH, group of not atom, two atoms, CN, C double bond oxygen. Okay, that meaning Z maybe just one atom, maybe groups of atom. The second type of reaction for diazonium salt is the coupling reaction. Okay, this is the diazonium salt. This here between N2, it will be make a new bond between nitrogen and this carbon here. On this carbon, give you this azo compound. طلبة دائما R N double bond N R, this functional group N double bond N, we said azo compound. Okay, as for example C double bond C. What is the C double bond C? Alkene. C triple bond C, alkyne. Okay, COOH, carboxylic acid. Not like that. N double bond N, azo compound. Azo compound. Okay, so this it will be entered to the coupling reaction, and we said here why on the second part of the coupling reaction is what? NH2 or NHR or NR2. That meaning is a primary aromatic, يعني primary aryl amine, or secondary aryl amine, or tertiary aryl amine, or maybe chia OH phenolic. Okay, what is the feature on this group? What is the work of this group? Look, they are what? Strong electron donor group. شو معنى strong electron donor group? يعني this benzene ring here is activated or deactivated? Donating. أبا donating يعني activated. Okay? Oh, that meaning diazonium salt, it will be entered to the coupling reaction, and the second part of the coupling reaction is activated aryl compound. Activated, not deactivated. Activated aryl compound. Tamam? Clear? Do you have a question? No, we go to the specific of the substitution reaction one by one. Okay, we study how the aryl diazonium salt react with various reagents to form products of Z. Z, I say to you, maybe just one atom or groups by replace N2 يعني substitution يعني تبديل replace. So very good leaving group. دائما طلبة N2 is what is good leaving group. The N2 is good leaving group. Okay, it will leave the structure as what? As what? As N2 gas. As N2 gas. As N2 gas. Okay, as N2 gas. So the mechanism of this reaction varies with what? With the identity of the Z group. That meaning this has a special mechanism. This has a special mechanism, different mechanism here. In this chapter, we don't study the mechanisms. Okay? We don't study the mechanism. Just we take the reaction without mechanism. Okay? Without mechanism. Just we take the reaction. So the main idea here again is replace the diazonium group by what? By Z. This is the main idea. The main idea here. And we have N2 is good leaving group as a gas. To leave the structure as a gas. Tamam? So first one is the produce the hydroxyl group, the aromatic hydroxyl group. We said OH phenolic, yes, OH, the hydroxyl phenolic. To produce the hydroxyl phenolic. As you know before that, if I want to produce, for example, CH3 group, how I can produce CH3 group on the benzene ring? No, produce, يعني from the benzene. From the benzene, how you can prepare this compound? By alkylation. Okay, alkylation. Give you alkylation here. Okay. If I want to produce BR, bromination, BR2IL, Lewis acid. Okay. If I want to produce, for example, this acylation. Okay. If I want to produce SO3, okay, NO2, nitration. Look, then if I want to produce here OH, okay, there is no this type your reaction. So to produce OH, there is no one reaction give you hydroxyl group on the benzene ring. There is no your reaction. Okay? So what we have to do, we have to go by using what? By using diazonium salt. We have to go to make nitration, and the nitration, must be converted to the NH2, and the NH2 convert to what? To N2Cl. Tamam? And the N2Cl just with the water give you what? Give you phenol. Okay, give you phenol. Tamam? By this way we can produce the hydroxyl group. Okay? By using what? By using diazonium salt. So directly diazonium salt react with water to form what? To form phenol. So if I want, for example, we know bromination, we know chlorination, yes? But if we want, for example, fluor, there is no fluorination. Why there is no fluorination? Because we learned before that the fluor is so active, cannot be controlled for the fluorination, for the halogenation of the type electrophilic aromatic solution. The same way, if I want the iodine, also cannot be useful for the halogenation. Why? Because the iodine is very what? No, it's very inert or very slow in the halogenation. Very slow. قلق بطيئة. Okay, very slow. So, substitution, we go by using diazonium salts, okay? It is like, do you take it in another chapter, Sandmeyer reaction. Sandmeyer reaction by using diazonium salt. Here, substitution by chlor and brom. Diazonium salt can be reacted with CuCl, copper chloride, or copper bromide to produce the Cl and the Br groups. Okay? To produce the aryl chloride and the aryl bromide. Okay? Without mechanism, just we take the reaction. Do you understand? So, this reaction, طلبات, is like any reaction to produce brom and Cl. Yes, bromination and chlorination, the halogenation. It is like the halogenation. Okay? Like the halogenation. Now, if you want fluor, the halogenation cannot be produced the fluor. Why? Because the fluor is very, very active. So, but by using diazonium salt, diazonium groups react with HbF4 is the what? A fluoroboric acid. Diazonium salt react with the fluoroboric acid to form what? To form aryl fluoride. This is useful reaction because aryl fluoride cannot be prepared by directly halogenation. Why? Because the fluor is what? Very, very too active here. Volatile. Okay? So active. The same thing, if you want to produce the iodine cannot be produced by halogenation. It will be produced during diazonium salt and it will be react with NaI, sodium iodide, or Ki, the potassium iodide, to give you the aryl iodide. Okay? To give you the aryl iodide. Do you understand? Without mechanism, just the reaction. So, Cn, substitution by Cn group is the natryl group. Benzonatryl. This is the benzonatryl, talaba. So diazonium salt react with cyanide to form what? To form benzonatryl, because cyano group can be hydrolyzed to what? To carboxylic acid. Look, this number 1. Cn, it is a useful group. Why? Because Cn can be hydrolyzed to what? To the carboxylic acid group, and can be reduced to what? To amine or aldehyde. Can be converted to what? To ketone. Also with organic reagents. This reaction provides easy access to wide variety of the benzene derivative using an organic chemistry. So the Cn group, طلبة, this is the Cn group. This Cn group, they are useful in organic synthesis. Why? Because can be converted this Cn group to another groups. Another functional group. Okay? Another functional group. Substitution by hydrogen. Look, by hydrogen. Diazonium salt can be converted to the hydrogen. And this reaction is, has limited use in organic synthesis, but useful. But unlimited. Okay? Unlimited. Why? For example, if you have some group, and this group, it is make مثلا side reaction or side effects, or you want to remove this group to make different biological activity to test it your compound in medicines. So you have مثلا this compound, and you have, for example, you have here NH2, okay, and this NH2, and you have many groups here. Many groups, or maybe another groups here, like that. Many groups, structure. And you want to cancel this group, to reduce this group. Reduce this group to convert the NH2 to what? To the hydrogen. How? During what? During diazonium salt. Okay? Diazonium salt. Diazonium salt can be reduced to the hydrogen by reaction with H3PO2, the hypophosphorus acid, this is the H3PO2, and it will be, I say to you, this reaction has limited uses in organic chemistry. For example, if we want this, Okay, if you want this, for example, from the benzene, prepare for me this compound. Br. Okay, without diazonium salt, can we prepare this compound from the benzene? Okay, خطوة أولية. What is the first step of bromination? Give you Br. Okay, this number one. Br. خطوة دوية. The second step, her bromination. But this is ortho para director, not meta. But here, our group, they are meta director. Okay, what you have to do, this here, it is not useful, huh? False, not useful. Another halogenation, not useful. What we have to do, we have to go to the nitration, yes. Nitration, give you what? Give you NO2. Okay, NO2 ortho para or meta director? Huh? Meta, عافية, meta director. Bromination, give you Br, NO2. Now, NO2 to the diazonium salt. Give you what? Give you طبعا لازم reduction. Reduction يعني بدنا NH2 وصى خطوة أولي باي NH2 HNO3 تمام؟ وعاد بدنا diazonium salt N2Cl. This is the diazonium salt. Okay, how diazonium salt convert to the Br? By CuBr. خلاص. Give you the product. Br. تمام? Okay, look. This number one. Okay? So, another example, my next slide, to reduce the diazonium salt to the hydrogen, this. Look. Now, I want to prepare this compound. And this group is ortho or meta or para to each other. No, this meta. This meta to this, and this meta to this, and this meta to this. Okay. Number one, any group, they are meta director, as we said here, is the NO2. Okay, nitration, NO2. Reduction, aniline. Now, the aniline is here, ortho and para director. Ortho, para director. multi-bromination. Access يعني طلب multi-bromination. يعني bromination number A وbromination number 2, bromination number C. Okay, 3 times bromination give you this compound. Now, I want to remove the NH2. How I can remove the NH2? By using diazonium salt. Convert to the diazonium salt and then diazonium salt with H3PO2 to give you the hydrogen. Hydrogen here. Okay, the hydrogen here. Oh, it's not working. I don't know why. Okay. Now, using diazonium salt and synthesis. Okay. What he said, diazonium salt provide easy access to many different benzene derivatives. Yes, we can prepare many different benzene derivatives here. Keep in mind the following 4-step sequence because we will be using diamond, diazonium salt. When you work in organic synthesis, you need this step. You need nitration. And the nitration, you need reduction. And the reduction, you need diazonium salt. يعني أو 6 step أو أساسية. This 3 step, they are main steps in organic synthesis. Okay? They are main steps in organic synthesis. 4. Diazonium salt finally can be converted to the many different groups. Okay, can be converted to the many different groups. Okay, this. Okay, now we want to prepare this compound from benzene. Okay, from benzene. What we have to do? To have to think they are ortho or meta or para to each other. Meta. Okay, this is ortho para director and this ortho para director. Okay, this group comes from chlorination and this group comes from what? Diazonium salts. Okay, this group comes from diazonium salt. Diazonium salts, that meaning we start from nitration. Nitration. Start from nitration, and we will see next step. So we have to make nitration, step number 1, nitration. And the nitration is what? Meta director. Chlorination will be give you chlor at meta position, and then reduction to the NH2 and diazonium salt to the N2Cl, and finally H2O. It will be give you the hydroxyl group. It will be give you the hydroxyl group. Okay, do you understand? So how we can prepare this compound? This group comes from what? Bromination. Or this group comes from the cyano group, the SN. Okay, SN from the cyano group, SN. So cyano group from the diazonium salt. We know that. Look to the next slide. Step number 1. Bromination. Step number 2, nitration. Nitration go to the reduction, and reduction go to the diazonium salt, and finally diazonium salt with you to the CN. CN by using reduction with mild reducing agent give you aldehyde group. If you use strong reducing agent directly, this it will be converted to the alcohol to the CH2OH. Okay. For you have to use here mild. I think it will be repeated reducing. This reducing of the SN group with this compound diisopropylamine. It will give you mild reducing agent. It is not strong reducing agent, and it will be give you the aldehyde group. Because if you use strong reducing agent, the aldehyde group, it will go to the further reduction and give you alcohols. Okay? Give you alcohols. Is it clear for you? What we have, next slide, another example. This homework. Draw the product formed of each reaction. Aniline, خطوة أولية diazonium salt, first step diazonium salt, and with copper bromide, give you what? Give you? Yes, give you aryl bromide. Bromobenzene give you. Okay. For example, this diazonium salt, this it will be go to the diazonium salt. With HBF4, fluor. Tamam? Fluor. So, devise of each compound from benzene. I want to prepare this compound from benzene. This is during what? Halogenation directly? No, there is no fluorination. By using diazonium salt. Okay. This I use nitration and hard reduction, and then you have to resolve this problems. Okay. And this it is same for this exactly for the example we take it before that. Where is it? It is same to this. Same. Where is it? Same to this, exactly. Same to this. The same procedure. But the final step, not the final step, this the bromination will be chlorination. Just we have different here. Okay, we have different here. So do you have a question? No questions? Okay. Coupling reaction of aryl diazonium salts. Coupling. Now we finish from the 1 minute from the substitution. Subject to finish this chapter today, inshallah. So the coupling reaction of aryl diazonium salt. The second general reaction of diazonium salt, that coupling. Okay, coupling between two parts. You have two parts. It will be joined to each other. We say coupling. So when diazonium salt is treated with what? With an aromatic compound. Look, with an aromatic compound, not aliphatic. Okay, aromatic compound that contain what? That contains strong electron donor group. So this is the diazonium salt. We prepared already diazonium salt. It will be go to coupling with this part. This part has what? This Y has strong electron donor group. Okay, strong electron donor group. The two rings join together, as I said to you before that, to form what? To form azo compound. And the functional for the azo compound is what? Is the nitrogen, double bond nitrogen. This is the functional group for the azo. We said azo compound. Okay? We said azo compound. So, compound with nitrogen, nitrogen double bond, this is the azo compound. So, this group must be what? Must be donating group. This group must be donating to make this benzene activated. To make this benzene activated. Why? Maybe some of you, it will be asked why it will be donor, it will be activated by link, because this here, diazonium salt, without this the negative charge, is electrophile or nucleophile? Positively charged? Yes, electrophile. So this it will be worked as what? Nucleophile. So it will be go to the electrophilic aromatic substitution. Electrophilic aromatic substitution. This it will be point to here, substituted to here. Okay? Remove hydrogen and put this group here. We say substitution. So must be this ring, activated ring, to be able to work as what? As nucleophile. To be able to work as nucleophile to attack the diazonium salt as electrophile. If you want why this is it clear for you? So the coupling is the coupling between two parts, between the diazonium salt and aryl. Okay, why we said aryl here? Where is it? We said in a second, is the diazonium salt treated with what? With aromatic, yes, with aromatic, with aryl compound. Why we said aryl? Because the mechanism is here is what? Is electrophilic aromatic substitution. So it is just special with the aromatic compound. So for this reason, we said this part must be aromatic because the mechanism is electrophilic aromatic substitution. Is it clear for you? Clear? No notes. There's no notes. Okay. So azo compound are highly conjugated. Okay, we said azo compound, talaba, meaning what? Meaning the conjugated, meaning we have conjugated system. Double, single, double, single, double, single. If you look to this azo compound, look, this the benzene ring, they are conjugated, yes? And the conjugated continuous with this also, with single, double, single, double, single, double, okay? That meaning we have here azo compound, they are highly conjugated, okay? They are highly conjugated. When the compound has highly conjugated system, diamond, always they be colored, okay? They be colored, can be worked as colored. They have colored, okay? So for this reason, many of this compound, such as azo compound, okay, better yellow, okay? They are yellow color. So our synthetic dyes, this dyes, sabra dyes, okay, صناعية, they are synthesized, okay, from what? From diazonium salt coupling, Butter yellow as once used to color the what? Margarine. You know what meaning margarine, yes? Margarine, semen. This is the thick oil, okay, zibda, semen. They are derivative from the plant oil, not from the animal oil. Okay, so this colored, this dyes used to color the margarine, to give the margarine the yellow color like original color. Yes, this is used for the margarine. So diazonium salt now, for this example, look, it will be make coupling with this part. This part is aromatic part. What we have here, we have nitrogen CH3 by 2. These are donating or withdrawing group? Donating. Why donating? Because we have unshapophilic electron here, donating by resonance. Okay, donating by resonance. So it will be give you this, the manufactured dyes. This way we said better yellow, they are used to color the margarine. Okay? So during what? During diazonium salt coupling. This reaction now, is another example for what? As I said to you, for electrophilic aromatic substitution. For this reason, this part, it will be work as nucleophile, must be activated part. Okay? Must be activated part. So, example for what? Electrophilic aromatic substitution. Can you give me another examples for electrophilic aromatic substitution, like any reaction, if you remember? Okay, halogenation for the aromatic compound. Yes, nitration also, alkylation, sulfonation, acylation, alkylation, all of this. Okay, all they are electrophilic aromatic substitution. So the nucleophile, the mechanism is the same mechanism, but we have different here between the nucleophile and electrophile, but the same mechanism. If you remember, the mechanism is two-part mechanism. Part number one give you what? Give you carbocation, and the carbocation has resonance structures. Okay, resonance structure. The second part is what? Is elimination of the hydrogen, and our aromatic system, it will be formed again. Okay, this is the mechanism, just two-step mechanism. So with the diazonium salt acting as electrophile, like all electrophilic substitution, we now take it. The mechanism has two steps: addition of the nucleophile, addition of the electrophile. Yeah, the nucleophile, it will be attack the electrophile to form what? To form resonance stabilized carbocation. This is the carbocation. Look, we have positive charge on the carbon. This is the carbocation. And this carbocation, what we has plus 3 additional resonance structure. That meaning we have resonance structure here. Okay? We have resonance. Yes. If I say to you, the question, say derive the mechanism for the diazonium salt coupling, you have to write complete mechanism. This and the other resonance structure. Okay? And other resonance structure. So, stabilized by carbocation. The carbocation is stabilized by resonance, followed by what? Deprotonation. This is the khutwa, this is the deprotonation to give you the aromatic system again. So, as the mechanism is two-step mechanism. This, as we know, the one of the double bond. And this, when this group is donating, the orientation, it will be orthopara or meta? Huh? Orthopara. All the activated group, they are orthopara orientation, yes? Okay, so for this reason, the substitution will be happened here, ortho and para. Because this electrophile is big electrophile, the better substitution will be happened here on the para, open area. Okay, there is no problem, there is no steric effect. Okay, there is no steric effect. So, the double bond here, the double bond, it will be open to attack this nitrogen. And the triple bond here, one of the pi bond, it will be open to the nitrogen to give you this. To give you this carbocation. We have positive charge now here. Okay? The positive charge now, the carbocation is stabilized by resonance. This the double bond make pi bond, and the positive it will become to here. This pi bond make and the positive come to here, like that. Okay? You have to try to. No need. The para is the best substituted. Why? As I told you before that, because here what we have open here. This is open, and there is no steric effect between this the bulky electrophile and this the Y group. Okay? If your Y group like that, look this big group. Yes? Not a smaller group, not NH2. It's substituted nitrogen. Okay? So if both of them, this big group and this big group, the substitution is preferred for what? For para position. Yes, for para position. Okay? You understand? So, okay. Do you have a question about the mechanism? Is it clear for you? Mechanism? Okay. Now, because diazonium salt is weakly electrophile, okay, the reactions occur only when the benzene ring has strong electron donor group. As I told you before that, they are activated group. Okay, the benzene ring must be what? Must be activated benzene ring. Okay. Any group, example for a group, for donating group, example for donating group, NH2, the amines, also the OH, the hydroxyl group. They are donating by what? By resonance. They are donating by resonance. He said to determine what starting material are needed to synthesize the particular iso compound, always divide what? Divide the molecule into two components. If anyone like that, if I told you I want to prepare this compound during diazonium salt. Look, I want to prepare this compound during diazonium salt coupling. Okay, so the coupling, if you look to this compound, the coupling may be come from here, this diazonium salt, and this the aryl part, or the coupling it will be come from here. This the aryl and this the diazonium salt. Okay, you have to know anyone is the better than other. Okay, if you want to cut from here, okay. So look to me. Always we say diazonium salt, it will be make coupling with activated benzene ring. So this group is what? Donating, activated the benzene ring. This benzene ring, this is benzene ring, it is activated. Okay. Look to the other benzene ring. This group is what? Deactivated. So anyone is the better. This diazonium salt, it will be with this group or with this group? Yes, it will be diazonium salt, it will be with the deactivated group. That meaning we have to cut from here. Okay? You have to cut from here. And this part, it will be related with diazonium salt, and this part, it will be related with the aromatic benzene ring. So, and make coupling between of them. The reaction will be okay without a problem. So, the same idea here. Once, he said, one has benzene ring with diazonium ion. Yes, anyone it will be diazonium salt. This the diazonium ion. Diazonium ion means diazonium salt. Okay, and one has benzene ring with very strong electron donor group. So this is the donor group. This is what? Yes, the diazonium salt. So we have to cut from here, not from here. If you cut from here, this benzene it will be without a group. It is not activated. Okay, not activated. So your reaction will be not success, okay, in this time. So you have to cut from here. This is activated benzene ring, and this is the diazonium salt. So if you make now coupling reaction between this and this, give you what? Give you this. Okay? Is it clear? So what is starting material? I needed to synthesize the following compound, this compound. Any starting material, I have to cut from what? From here. Why? Because the diazonium ion, it will be with the deactivated benzene ring. And the other group, it will be activated benzene ring. And the coupling, it will be happened. With high percentage. Okay? With high percentage. طبعا this compound, methyl orange. I think you use the methyl orange in analytical lab, yes? If you remember, this is the methyl orange. Methyl orange is as a compound synthesized. Do you understand? Here, another question. Draw the product formed when this compound, look, we have benzene cycle here. This compound react with each compound. That meaning the diazonium salt with one benzene ring react with this. Okay, with this. What is the product? Write the product. The substitution, it will be happened what? It will be happened here in the para. N double bond N cycle, yes? Okay. Write the compound when this diazonium salt react with phenol. Substitution, it will be happened here. Substitution. Okay? Write the compound when the diazonium salt react with this dihydroxybenzene. Okay, dihydroxy. This is ortho para blockade. This ortho para. Okay, the substitution will be happened here or here. The same. Both of them the same. Okay. As homework, write the mechanism. Write the mechanism for this reaction. Okay, write the mechanism. هر एक دو خطوة. For every compound, do step mechanism. Write it as homework for you. Okay. So, what starting material are needed to synthesize each as a compound? This as a compound. Okay. Now, during diazonium coupling reaction, look to this compound. I have to cut from here or from here? Huh? Why? Because if you make this part is the aryl compound, it will be deactivated aryl compound. And it is not useful for diazonium salt. So we have to cut from here because we have here activated the group and the the aryl compound, it will be what? The aryl part, it will be activated. And the reaction will be happened with high percentage. Okay, with high percentage. Okay, look to here. This CH3 donating, but by what? By inductive. And this donating by resonance. Or this here, deactivated group. So any part is activating, more activated, this or this. Yeah, for this. And this part must be the aromatic part. We have to cut from here. We have to cut from here. This, it will be diazonium salt. And this, it will be the aryl compound. And the coupling, it will be happen with high percentage. Okay? With high percentage. Do you have a question? Do you have a question? C? شنو CL? ايه CL ايه CL also is ortho para direction. CL طبعا by resonance. No, both of them is the same. Both of the same by resonance. Okay, you have to say half to half. Okay, so maybe substitution will be happen here, or substitution will be happen here, because CL is ortho para by what? By resonance. But who deactivated? تمام? Who deactivated? Okay. Do you understand? Okay, this chapter I think is finished to here. So many homeworks for you. You have to resolve the homework. They are important homework. Do you have a question? No question here. Okay. So let us talk about